Welcome back to the Gateway NMRAX. This is Brooks Willard coming to you live from the Hobby Time Workshop. I'm here with Tim Odenhoven, or Oudenhoven, right?
Oudenhoven, yeah, you got it.
Odenhoven, okay. All right. If you didn't catch his last video about cricket and in model railroading, I suggest that you catch that. And we're going to continue on with part 2, and you're going to talk about 3D printed parts, right?
Yes.
Cool.
So we're basically scratch building a train car using modern techniques. So I'm going to share my screen here, and we're going to go over to my little document that we've been using. All right. Brooks, can you see my screen?
I can.
Very good. So this is, again, the car that we're making. But there's a caveat here, is there is a modification that's been made to these cars. And that is this grading right here up on top, that some of the cars have that, TPPX. And I think that's a really, really cool detail. I'm not sure how I'm going to do that mesh yet. Maybe just use clear plastic that's just lightly coated or something like that. I've done that as well for fine mesh before. But I definitely want to 3D print this piece that fits on my gondola. So that's what I want to do for our project. I've already made the sides and stuff, but this will at least show us. But let's look at this part just a little bit more, and I'll kind of show you how I see it. So when I look at this, we have already made the side, if you looked at the last clinic, so we can just inset it in. But if we look at the edges here, it's like it's a flat piece, and then it's got a vertical piece that comes out from there. It's like an L girder. Notice how thin they are compared to my ribs. So my ribs I made, they are, we'll see what they are. I believe they're 1.5 millimeters thick. So we definitely want to make those a lot thinner. And notice up here on top too, you've got a flat piece with a piece that comes out. And down here too, you've got that sheet, and then it just goes right to the car side. So basically it looks like I can just make a sheet here, but I'm probably gonna make a little landing riser that rests on top of the side of my car, and then also make that on the side here just so it's easy to glue in. And it's nice that I won't be removing these, but it would be a retrofit piece for this car. The other thing we got to figure out is it looks like we got the flat pieces here on the corners. And then we got 1, 2, 3, 4, 5, 6, 7 of the vertical runners, and they seem to be evenly spaced. Okay, so with that in mind, I'm going to stop my share, and I'm going to go back into Fusion 360, and let's make this. So Fusion 360, here you can see our piece, and you can see the rails. And so what we're going to do now is actually make this. So I'm going to create a brand new sketch. I like using sketches for different things. So making multiple sketches versus one sketch that rules them all, make lots of little ones. It's important that you name your sketches well. I am being extremely lazy with this car. But again, remember, I made this in 2 hours. But usually I go back and rename them, and sometimes I do it as I go. But I'm just going to click on my styrene sheet side here, and I'm going to hit create new sketch. Now, the genius here that we just did, if you will, is my sketch is right over the top of that styrene sheet. Because remember, I want to put something behind it to mimic that meshing, which means it might be a 20 thou styrene clear piece that we can then make a grading pattern on, either with decals or just misting an airbrush over it. So the piece I'm making is going to be butted right up to my rails. So I'm going to hide a few things here. All right, and end break, there we go. And let's get this nice. All right, so now what we need to do is we need to draw the basic lines like we've done before. So I'm going to create line, and notice how it just pops right on the side there. I can come right here, and I have the first line. So Fusion 360 is really smart. It just kind of lines stuff up real nice for you. I'm going to hide my side rail, so now I have just the styrene, and I'm going to click on these. Oops. Right here. Okay, that's good. Now what we need to do is create that those triangular pieces in the corner. So what I'm going to do is just click down here. Notice how my cursor immediately goes to that corner piece, and I'm just going to go up. And I want a 90-degree angle. Go. And I'm going to do it over here. I'm just using the line tool. Go. Now notice I went over. It's faster. Just go over. I can use my trim tool, trim that up. Now I've got that piece. So I can actually give body and definition to these triangular pieces. So if I click on them, I hit my shift key, click on that. I want them to be thin, but I don't want them to be super thin. So I'm just going to choose to make these, let's say 1 millimeter. So I'm gonna hit the E key, do 1 millimeter, go. Okay, I have those pieces in place. I'm gonna show my sketch again. All right, so we got those made. Now what we need to do is that top rail. Now remember there was that vertical piece that comes out and then there was a kind of a flat piece. So I'm gonna click on this line right here and I'm gonna do what we call an offset, where it draws a line down below. So for that larger piece that comes out, my nozzle that I print with, I'm gonna print this with, is probably gonna be a 0.4 millimeters. So doing a 0.4 millimeter line is very possible for my printer. It'll be really nice and thin. It'll look really, really nice. So I'm going to do that. And if I zoom in, you can see I got 0.4 millimeters. I'm going to click on the line again, and I want to make that flatter piece. So right now it's going 1, which really means it's 0.6. I actually want it to be 1. I'm just going to make it 1. I think that sounds pretty good. We're going to do that. Perfect. Then I'm going to just revert back to my picture real quick here. Okay. Now what we need to do is the bottom piece. So if I come here, the bottom piece, I'm going to do the same thing. I'm going to do O. And first I want to make that rail that latch is against the bottom for ease. So I'm going to make that 0.4. And that'll rest against that side rail. And then I'm going to do a 1.4, and I'm just going to make them the same. Right like that. There we go. Now what we need to do is make the end brace. Remember there were 7 of them that went across. And it looks like this one right here has no side plating on it, if you will. So I'm just going to do O, and I'm going to do a 0.4. Boom. Done. Got that one made. Now what we need to do is start mirroring these across. So I'm going to select these 2. This is a really cool trick. There is something called a rectangular pattern tool. It is your best friend. So rectangular pattern, I'm going to set the direction. I want it to go across like this. And then I got to set the extent. I don't know what it is, but all I know is I need 7 pieces. And I'm just going to take a guess on the measurement. I'm going to say 100 for now. I could have measured that. Okay, 100 is not right. So we're going to 120, too far, 110. Almost there. It needs to be 109.8. Up too much, 0.6. So if I can do math. Okay, so 109.6 is the length. Notice you can see the line there, perfectly lined up. I now have 7 of these ready to go. I hit OK. And now I've just made all those lines for me ready to go. Let's go back to our picture and see what we're doing. I usually will use 2 screens, 2 computers, so I can constantly refer back. You can print the picture too, but I'm high tech. I guess I just use my computer. So it definitely looks like there's no thin piece on the other side of these ribs. It's just on the one piece. It looks like it's here, but it looks like I don't see anything over here. And I'm just going to assume that it's not there. I do have pictures from the other angle, and I can tell you, I don't know. But I'm just going to assume there's nothing there. I can always add it later. It's no big deal. So we're just going to create this one side, and I'll create it over here. So I need to create this piece right here. It looks to be the same thickness as that piece and this piece. So we've been making this 1 millimeter, so we'll just make those 1 millimeter all the way across. So let's switch back to Fusion 360. There we go. And we need to make a 1 millimeter piece. So I'm just going to do this line here, hit O, do -1, boom. And there it is. Now I need to put it across. But honestly, I could do that, but I'm just going to do it by manually because it's just fast to figure out that extent and measurement. Not really worth it just for a couple of pieces. But notice you don't have to use the fancy tools like a rectangular pattern. Notice how fast I'm just going by hitting the O key for offset, and I'm just typing -1. Boom, I've got them all. Now we're ready to go and give this thing some depth and some definition. So I'm going to start by doing all the smaller pieces first. Now, notice I have a lot of lines here, which is a bit of a problem. Now, I could go and trim all these up. It really isn't worth the time to me to do that, to be honest. When you can just select with the Shift key so quickly, I'm just going to do them by hand. Again, this is a crayon approach versus the number 2 pencil approach. But if I was, for prosperity's sake, the more correct way would definitely be to do all the trimming in that. But I'm going to guarantee you it would have taken me about 3 times as long to do that versus what we just did. Okay. All right. and I'm going to say extrude, and I believe we set those other ones at 1. I'm going to make a new body. Oops. 1. Okay. So now you can see we've got all of our pieces here. It's looking pretty good. Now what we got to do is create the parts that pop out more, those braces that come out more. So let's do that. So I'm going to go back into my sketch, right like that. I'm going to hide the side panel, and I'm going to edit my sketch. Okay, double clicking is your friend in Fusion 360. All right, now we just need to make those bigger pieces. Now, again, this is a little tedious because I don't have things chopped up like I want. So now I'm getting annoyed. So I'm just going to trim these because it's just going to get annoying. Now, when I did that rectangular pattern, I could have done the trim and did the rectangular pattern. If I was paying more attention, I would have done that if I wasn't trying to talk at the same time. But yes, it would have made more sense for me to draw the lines and then trim them and then do the rectangular pattern and do it 100% properly. But again, this is a very forgiving piece of software. We are good to go. Okay, we got that. And so I've got the trim key, which is the T key. You can just see they're all trimming up nice. Okay, so that makes it a lot easier for us. All right, so I'm just going to come in here then and go and make these. I'll do that. Do that. So I have not pre-modeled this. This is the first time I've modeled this piece, just for the record. So I wanted to kind of show authentically how it is when I first sit down to do this. And you can see it's really not too bad. In the Mac, I'm using the zoom in and zoom out feature on my magic mouse pad. That's how I'm zooming in so quickly. On Windows, I'm sure there's other keys and ways to do it. I just don't know because I'm a Mac guy, and it works very easily. Okay. So I believe I have these all selected up, and I'm just going to hit E. Now, I don't know. I want these to be farther out. I did one on the other one. So let's make this 2. And go. Okay. So now if we look, we have this piece looking pretty nice. You know, you can see, well, it looks like I got a styrene sheet here that I didn't want. There we go. So this is looking pretty nice. It's looking pretty good. Let's refer back to our photo and just see how we're doing. So I got 1, 2, 3, 4, 5, 6, 7. I always count those. I can't tell you how many times I've messed up when I'm making cars and I miss a rib. It's really annoying. Okay, here we go. So I notice there's a top lip right here that I need to put in yet. And then I do want to put this lip on the side so that it sits down into my car properly. So I'd say those are the 2 things we do. Do these 2 side top lips, and then just so it sits down in the car. So I'm going to go back into Fusion 360. I'm sorry I'm going so fast, but I hope we're all just kind of getting the basic concept versus how to do it. Just to show you another way to do these things. Let's say I don't want to go back in the sketch, but I want to draw this line forward. I don't have to create a sketch for everything. I can actually create a box. So I come here, create box. I tell it what surface I want to start from. I draw my box on here. We said it was 0.4 in height. Notice it's making the box. And now I can just click on this surface, and it draws it all the way across. Just like that. Notice we just drew that line without having to go back to sketch. Now, do I have it in the sketch? Yes. But there's many times of the just get the project done mode that it is kind of nice just to play with boxes. And it's a lot easier. But there are, just like many things with tools, there's multiple ways to do things. Okay, so we got that done. But now what we need to do is draw in the lines that go on my gun. So I am going to go back to the sketch. All right. Now, I don't have this line drawn in. If we look here, I'm going to put in my side panel. This line isn't here. So I need to draw this line right here. Boom. And then I'm going to make an offset. And the offset's going to be a negative 0.4, which is what we've been drawing everything. And then I'm going to go over to here this side. Draw the line. Now, could I be mirroring these things? Of course. Mirroring takes more time. It's just easier to do it sometimes. Oops, this is positive 0.4. Good. All right. Thank you. There we go. All right, so now I'm just going to select this. Select this. All right. Select that. Looks like we got a little fiddly bit right here I could have trimmed out. We'll just select it regardless. Okay, oops. I'm just going to do this for right now. So I'm going to do this as an E. I'm going to do 2 on it for the distance. And I'm going to hit OK. So notice I only did one side, but notice it looks really, really nice. So I don't want to do more than that. I'm just going to mirror it. I'm going to mirror this part. So I click on the part, which is body 100 right now. I go create, mirror, select. I always model my cars directly in the middle of the origin, which is right there. I hit that base, which is my middle cut point. Hit OK. Notice it just popped right over there. Now what I need to do is extend this edge all the way across. I'm going to hide my side panel. And, oops, zoom in. Work with me, work with me, work with me. We're on live television. Okay, it's being fiddly, but that's okay. Multiple ways to do these things. So sometimes I find that I'm not able to zoom in and out as well as I would like. But there is this zoom in feature, if you will, that you can use, where I can just draw. Come on. Yeah, it's not liking me right now, but that's okay. Multiple ways to do everything. I'm just going to join these. Combine them. It's called the combine tool. Okay. Now is it working? Yes. Okay. No, not quite yet. It's being a little ridiculous. Okay. And I select this face. Come on. So I need to zoom in just a little bit more, but for some reason she ain't zooming in on me. And at this point, this is when I would restart Fusion 360. Sometimes it gives you headaches, and it might be the sharing software we're using. Can I do this? There we go. Now it's gone. Good. Okay. So again, just play with it. But notice I selected this edge I need to put across. I'm just going to hit E, which is the extrude key, and I'm going to go to the other side. I'm just going to click over here. Notice it shoots across. I hit join. We're done. The other thing I want to do is these top surfaces right here. Notice in my quick modeling, it doesn't quite have those edges right. I can just click over here. Again, we're having trouble. There it goes. Don't know why it's doing that. Must be the sharing software. All right. There we go. I can click on this bit right here. And this can get extruded up. The thing is, it's going to try to extrude straight up. So it's actually easier for me to go back to my sketch and draw these lines up. So like I said, there's multiple ways to do things, but sometimes there are easier ways. And doing that extrude was not the easier way. Okay. Looks like I didn't draw my lines perfectly, but again, for video purposes, I'm okay with that. So I'm just going to, oops. All right, and I'm going to hit E on that and hit 2, which is what we're doing it as. New body, good. Okay. Okay, yeah, you can see I botched that a little bit, but you know, are you really going to notice? No. If I was doing this for reals, I would have fixed that. And I'm just going to do a mirror. I'm going to put it on the other side as we've been doing. Okay. Combine up these things that we've got. Okay. So if we look at the time right now, I just modeled this whole thing in 10 minutes. If I wasn't talking, it would have been a little quicker. But we literally have a pretty close to a printable part. The one thing that we messed up on, or I messed up on, is notice when I made those triangular pieces, it did the whole thing, which I'm a little annoyed about right now. So we need to make that triangular piece. And we need to make sure that when I click on it, it doesn't go all the way across. So we want to just do this pieces. So E.5. Oh, no, we did those as 1, sorry. Actually, that might look good 0.5 just to give a little distance. Let's try that. Add a little detail to it. Now you got a little relief there. I don't know if that's in the original, but that looks kind of cool to me. So I think I'm going to keep it. That looks kind of neat. All right, and combine these up. So there we go. Now let's look at our side panel, and we'll put the side rails on. Let's side panel, side rails. There we go. All right, let's just see how it's fitting in there. So it looks like we've got a little bit of a lip here. It's not exactly flush, but I'm okay with that. And notice on the back, we did make that pocket that I could put clear styrene or netting or a brass etch piece on there very easily. But we got a pretty nice piece, I think, right here. So let's say now I want to produce this. I want to 3D print it. We can go through that right now. So I'm going to name this. Rename. There we go. And I'm going to call it side panel mesh piece. Okay. In Fusion 360, if I want to make it, so 3D printers, you have to start what we call an STL file. That's like their favorite file format for like a 3D object. Just like you have JPEGs and PNGs and GIFs for images, you have STL files for a 3D model. And so I'm just going to save as STL. Okay. And I'm just going to call it side panel mesh piece. That's why I wanted to rename it first. And there we go. Rename it. Now what I need to do is to go into my slicer software, which I'm going into right now. But before I do that, Brooks, do I have any interesting questions? I'm back on my camera right now.
Yeah, I've got a few questions. Let me get over to the tab. You ready?
Yes, I am. I'm
okay.
back.
All right, cool. When you're doing the car design in Fusion 360, do you like modeling each part separately in separate files and then combining them all together, or modeling the whole car in the same file and then exporting each part?
So separate pieces, because you're going to create a kit. So I model pieces per my kit. So as I'm modeling, I'm already thinking about what my kit going to look like. So for instance, the sandcar inner piece is one piece. Of course, there's multiple pieces. You can see all little pieces, but it's one piece that I made. So yeah, I'm always thinking about the kit. So in my Fusion 360, the number of pieces I have refers to the kit itself. But yes, as I'm going, you can see where I was combining individual elements, but I want like that side rail to be like a retrofit piece, but I could easily just print it with my side rail and combine my side rail and then that top side rail piece we just made and make that one piece next time I print. So it depends how I think it's going to be easier for the manufacturing to put them together. I want to make my modeling as easy as possible. I have no need to show off my craftsman skills. No need. I have no need to show people I can file or super glue well. The less I can do, the better. Remember, the best part is no part.
Right. When you're 3D printing parts, can you print parts thin enough to use in place of what you would typically use a photo etch part for?
No.
Okay.
So the nozzle on these, if you think of it, is actually a cone, and it's got a little hole in the middle of the cone, but you've got a lip around there that's flat. And the hole's in the middle of that flat circle. The problem is if I print anything, any line that is parallel, but is underneath the thickness of that edge between the hole and the edge of the nozzle on the bottom there, it's just going to goo it all to heck. It's going to be like a gooby mess. And so that is my limiting factor. I have been tempted to buy a cheap lathe and make my own nozzle that has like no hole, which means I could make like grating for grain cars and stuff. So I can make grating as long as it's straight and rectangular, but the ones with the holes in it or some of the more complicated grating I can't do right now because of the way the nozzle is made. And I'd like to make a custom nozzle, which might get rid of that. But the nice thing about having that flatness is it gives you nice, buttery, smooth surfaces. You can just see the bottom of this piece. I don't have to file this out. I can put my truck right on top of that, and she's going to run beautifully. And so the nozzles as they're made right now make a lot of sense. They make for nice, flat surfaces. But I'd like to make one that's more pointed with no flatness or very little so I can print tighter.
Cool. And then I've had some experience using Fusion 360. What's there's a Presspull tool and an extend tool. What's the difference? Because to me, they both do the same thing. Have you found any difference between them?
I'm using Extrude. Presspull takes in other constraints of angles and stuff into dimension, and I just find that sometimes it does things I don't want it to do. So that's where instead of using the Q, the push-pull, I'm always using Extrude. I just find that to be, for me, a lot quicker, and it's a lot more predictable, where push-pull takes other things into account. If you look up on Fusion 360's help desk, there's an article all about Extrude versus push-pull. And for flat surfaces, Extrude is the way to go. If you're doing curved surfaces, try the push-pull, but it gets really, really nuts. For instance, like this bowl right here has multiple complex curves on it, multiple profiles. It's got chamfer. It's got some cheeking going on. Of course, it's got the hull. So I'm using some push-pull and stuff and more complicated locking and stuff to make these. But for simple car shapes, E is your friend, Extrude. E for easy.
Cool. And then when you're exporting to the STL file, what method are you using to do that?
I'm doing it right out of Fusion 360. So you basically
All right.
right-click on your body, which is the part that's 3D that I've extruded and stuff. You right-click on the body and hit Save as STL, and it pops out an STL right out of Fusion 360. It's
Okay.
really
I asked that because I've been doing some designs and I found two ways. There's an export way, and I did it that way. And when you're doing cylindrical or curved objects, when I bring them into the slicer, they wind up being, like not curved. It's just with the facets are straight. And I wound up, there's like a 3D print that I seen in there, and I wound up doing it that way, and it seems to export it correctly. So I wanted to, if anybody had problems with it.
Probably not in Fusion 360, because Fusion 360 is giving you a nice curved image.
Mm-hmm.
It's your slicer setting, and you got to set the number of facets for a curve, because really 3D printers can only work, basically it's not 3D, it's 2.5D. It can only go left, right, front, back, and so it can only print in straight lines. So even a curve in my 3D printer, it's making it a whole bunch of little straight lines to make that curve, and you can set how many little straight lines you want. Now, the reason that a lot of them are set low is because the cheap Chinese printers have really cheap processors, and they can't handle all the little lines. They get bogged down. But I run Duet 3D boards, which have 32-bit processors and tons of memory. And those things, I mean, they got 5 times the processing power that the lunar lander had going to the moon. It's incredible what those things can do. And so I can set like 256 little lines in a quarter turn, and it does a beautiful job, and it never misses a beat. And so there is a consideration on the actual hardware of the processor on the printer. The solution is slow is better. So if you're having trouble, just print slower, because then the processor will keep up. But like my printers, I'm printing 100 millimeters a second on a regular basis with linear rails and Hermé extruder. For the geeks here, we know what I'm talking about. I've got pretty premium parts that I'm able to print really fast, and my printer never skips a beat because it's got a really good 32-bit processor in it.
Cool.
The Duet 3D board is a $250 upgrade. If you can do a lot of 3D printing, it is well worth it.
Cool.
So that costs more than people buy.
What material are you using to print these cars with?
That's a great question. I was going to get into that, but when we talk about it now, so there are multiple types of plastic for 3D printers. The most common that the 3D printer hobbyists use is called PLA. It's made out of cornstarch. It's actually a byproduct of the ethanol process. And so I've got a plastic pellets part, but PLA is a great plastic. The problem with it is it gets brittle. It doesn't like sunlight, and it's got a really really low transition glass temp. So if you leave your parts like in the car and it's hot out, it will melt before ABS or styrene. Styrene melts at a higher temp. But PLA is really good because since it is a lower temp, it doesn't string and get gooey. It's easy to get nice, crisp, clean parts. In fact, these rails are actually printed with PLA, and just notice how fine those ladders are that I printed. Just look at how fine that is. That would be really impossible to do in ABS, which you can print in 3D printer. ABS can't do this. It never bridged that gap. They just get a gooey mess trying to do that. There is a happy medium between ABS styrene and PLA, which is called PETG. PETG, PET is what they make milk bottles out of, and then G, they add a glycol to it to make it just a little more fluid. But PETG is a really happy medium. I tried printing ABS styrene. No, don't do it. No one in the 3D printing hobbyist world recommends ABS. Maybe they do it for manufacturing and some prototype stuff, but PLA and PETG, when you get your printer, buy both. PETG is nice. It's more flexible. It's much more heat resistant, and it's stronger because it's not brittle. So like these GBW cars, I can squash them, and I can really torture this thing. This is all PETG, and still notice how clean it prints. Just not quite as good as PLA. So I'm really printing fine stuff. I print PLA. This door right here is printed in PLA. And just notice how I got the door rods and stuff printed and little risers. It's just super clean. PETG just can't quite print as clean. So that's my marker, is strength versus cleanness. It's always that term. Now I'll have cars with PETG and PLA parts in them. I'll do both.
Cool. What model is your 3D printer?
So my I've upgraded. So I started life with an i3 printer. It was a Wanhao i3. It had a 8x8 print capacity. It's very comparable now to your Enders or your basic CR10s by Creality. A lot of the other printers you can buy. It's a Chinese kit. The Wanhao. It was really nice printer. I still got it. Got linear rails, round rails on it. Love it. But that was too small, so I upgraded to CR10 S4s. Which have a 16-inch by 16-inch bed by 16-inch height. So I'm able to print my huge 40-inch Cardex in 4 pieces now versus having to print them in 8 or 16 pieces. Bigger printers mean more headaches. So I've upgraded my CR10s with linear rails. 3D Fused makes wonderful, wonderful retrofit kits with CNC aluminum parts. I put new extruders on. I printed all my own brackets. I've got Duet 3D board. I got Wham Bam flexible build plate that I use now. I've upgraded the heat bed on it. I've done structural reinforcements. My printers are Frankensteins. I've got 2 of them now that run, and with the Frankensteining, I can really print good parts. You can go out and buy a $3,500 printer, and it'll work pretty well out of the box. But I have printers with $1,400 now, and they print almost better than the $3,500 printers. But again, it took me a while to do it. My recommendation is that you can buy really cheap printer kits for $80 or $100. ANET A8 used to be really popular for this, where everything came in a box. You had to assemble everything, do all the wiring, all the tightening, everything. Buy that. It's the best $100 college course you can ever have in 3D printing. If you're serious about it, build your own kit because you really learn how these things work. And so I had the Wanhao, and then just for the kicks and giggles, I bought an ANET. I built it during a Super Bowl. It took me about 3.5 hours to build. And never got it working well. Never planned on getting it working well. It's dirt cheap. It's cheap parts. But you know what? It taught me everything I needed about 3D printers that when I got my CR10s and Frankenstein them, they work beautifully. And I'm getting beautiful, beautiful parts out of them.
Cool.
So this is a hobby in itself, and you have to see it as a hobby in itself. So I went full bore 3D printing for 2 years and kind of left the model trains behind. Didn't quite do as much. I do 5 projects at once usually, but most of my stuff was 3D printing for 3D printing's sake before I could actually start making model train projects. And realized 5 years ago when I was doing this, there weren't many people doing it. There weren't printers you could buy for $200 that just work. Everything had to be botched and bashed and broken and fixed. Nowadays it's a little bit easier, but still, I think the hands-on approach is the way to go.
Yeah, I've been down the same road. I started out with the TiVo Tornado and went with the Prusa i3. And the TiVo, I'm wanting to upgrade parts for it, and I mainly still have it because it prints big volume stuff. So, but
so the printers are awesome, but again, they're pricey. But then the priciness gets you a printer that works pretty much out of the box with a little bit of tweaking. So if someone's got the money, buy a Prusa. Buy a Prusa. It's a wonderful printer. I've seen them run. But again, for what I'm doing, I wouldn't touch a Prusa. My machines, they're exactly what I want. Dial it in. Real fine stuff. It'd take me a while to get a Prusa working like that.
So what size is your nozzle that you're using, and then what layer heights do you like printing at with the fine detail?
So it depends. So I'm printing 0.4 millimeter nozzle is your standard. I do a lot of 0.2. I do have a 0.15 as well that I'll use with the new Hermès extruders. Best extruder I've ever gotten. With direct drive, 0.15 is possible now, and it's really cool, super fine. But again, you got the problem of the little hole in a bigger round plate, so you can't print lots of parallel lines. But for really fine parts, but I do a lot of 0.2. So this was printed with 0.2, so I get the ladders right and stuff, where this was printed with 0.4 for speed. So this printed in a half an hour. I could have printed it faster, but slower is better. It doesn't break as much or mess up parts. But if I printed this in 0.2, this probably would have taken an hour and 20 minutes. For layer heights, the rule is you never want to print, you always want to no more than 2.5 ratio on your nozzle. So if I'm printing a 0.4, I don't want to print much over 0.25 layer height. And if I'm printing 0.2, I don't want to go over 0.125 for my layer height. 0.125 is the height. 0.1 is what I do all the time. And then if I'm printing roofs like this, so here's a roof that I printed. You can see just a really fine detail. And I've got like curved plates here. This is my 60-foot high cubes that I showed earlier. I printed a 0.1 layer height to get the back. And then once I got to the top, I actually started printing 0.5. And then it went down to 0.25 just to really get me that fine. So in my slicer software, I can actually modify and taper things and go smaller and smaller. So because my machines are so precise with the linear rails and the duet boards, I can print 0.25 layer heights very, very easily, which is like resin quality. And it prints really, really nice. And to be able to print something this flat, where I can just do a Rust-Oleum primer and throw it on the car and you'll never see it 3D printed, is awesome. And this has only happened, I've only been able to do this in the last 5 months. So I'm continuing to refine my craft, but I'm really happy to go print stuff like this now.
So you're not having to deal with the layer, cleaning up between the layers. Usually you get like banding, for the layers there, and a lot of people do like acetone or something to smooth it out. You don't have that problem?
It's not that bad. I mean, even here, I mean, just to show, it's not going to show well on the screen, but here's the layer heights. I don't think it's focusing. You're not going to see them. You're not going to see that. I can sort of feel with my fingertip, but when I put paint on this, you're not going to see it. I mean, you look at this car. Can you see layer lines on this? There's layer lines. There's 10 layers right there of plastic. Can you see that?
It's a little fuzzy, but yeah.
The angle slope. You really can't see it, even though this is 0.15, I believe, layer heights. And I did misspeak before, so I'm printing 0.025 anyway. It's really fine. 150 micron layer heights, you can't see that. Now, when I go down to 100 micron or 50 micron layer heights, which is this went down to 50 micron layer heights, you really can't see it at all. But that's the quality of the printer. If I had just a stock Chinese printer, even though mine were stock Chinese $800 kits, because of the size, the aluminum extrusion, I mean, I put $400 of linear rails on them, $200 extruder, $200 dry board. I got BL Touch for level height, the Wham Bam level. All the upgrades allows you to start doing stuff like this. But don't start 3D printing thinking you're going to print this. Start 3D printing and try to print maybe basic shapes like this end is. We just have basic things, basic ribs. Try printing a gondola. Don't start trying to print a complicated door, or for instance a car fare, interurban. This has been printed on resin that I did. Don't start with this. I'm printing signals right now. These signals cost me 10 cents to produce. I don't have this glued on yet. That's why it's off. But notice the platforms. These are the CN style, modern CN style. I mean, great detail. And these cost nothing to produce. Super easy to put together. It took me literally 5 hours to model it, and we're good to go. And one of the cool things about 3D printing is you can actually bend parts. And so that signal, here's the rail for the signal. And if you look here, notice how I have little cuts. I don't know if you can see it. See the little cuts right there? I put little V's on the back, which allows me to come and to bend this. See how I can just bend this up? And now I just bent it, and I've got I got the hexagonal railing that's on those, and just bent up. And so I created those little cuts on the back of it so that I can bend it. And since the plastic is a little bit bendable, I can bend pieces into place. So I'm making railings and hand railings. A lot of times I'll make little notches. That's just my bend point. Just like I score styrene and then it can break it or bend it, I actually make bend points in some of my 3D parts, so I can do that as well.
What do you use to glue those together?
So PETG responds to methyl ethyl quinone or your plastistruck and things like that, which is really nice. And then when I'm printing PLA parts, the Tamiya stuff has a methyl chloride, whatever, dichloride in it. But I really like Tamiya when I'm doing PLA. So when I'm doing PLA parts and putting them on styrene like this, I glued this all together with the Tamiya stuff. It sets within 5 seconds. It's great. It's thin. You'll never see your glue lines. And then I also use a really thin super glue to reinforce my corners. This is a really strong car. I mean, I can chuck this against the wall. It won't break because of the super glue reinforcing in it as well. So super glue, methyl ethyl meek. If I'm doing PLA parts with styrene, PETG parts with styrene, I use the meek, the methyl ethyl quinone. And then if I'm doing PLA parts, I use the Tamiya glue because that eats through the PLA really nice.
Cool. Have you looked at doing SLA resin Or
I have
what?
a resin printer, yes. I have one of the ones with the LCD screen. It's a Wanhao D7. It was one of the first screen printers to come out 5 years ago. I was a beta tester for them. I've got that. Resin is messy. Resin's expensive. Resin smells bad. Resin you don't want to get in your hands. Definitely not in your eyes. I don't like resin. I don't like printing in resin. It's a chore. It's like brass etching. Anyone can brass etch parts. Go hardware store, get the chemicals. No one likes doing it because of the fumes and the mess and the danger and eye protection. Same thing with the resin. It's just messy. And I mean, I do resin print. For instance, this car is resin printed. My Chicago North Shore cars. But I avoid it like the plague. And right now, I made this 4 years ago. I can print this on my Frankenstein printers now. So my FDM printer could produce this quality now if I were to print new ones. So I try to do everything FDM possible. But resin has its place. But again, I like playing with crayons. I like doing stuff quick. I like having fun. Resin's not fun to me. It's work.
Yeah, that's what I've heard, that it's really messy and you got to be careful with it. So
now Speed's trying to get me to get Formlabs printer. Maybe Formlabs is fun, but those are $3,000 printers.
Yeah.
My little D7 was $350, and again, I don't want to blow $3,000 on a tool that I'm barely going to use. Where FDM is just so flexible. So yeah.
Yeah. What are you using for your bed and doing adhesion for your part on the bed?
Yeah, so I've done a lot of different things. I've done like those blue plastic mats you can put in, the easy build knockoffs. I used to print on those all the time and use a spatula. I did that for years. I've done glass, love glass. Glass is perfect for doing these kind of parts. And then you use a product called Magigoo. Magigoo. It is the best stuff. It is magic, I guess, but it really is good on glass and on the easy tack, easy build, knockoff build plates that you stick down. The Magigoo is fantastic. But I've actually upgraded. There's a company called Wham Bam Systems out of Florida, and they make a flexible steel that's held down by magnets. You just pick it up and you just flex, and the parts come right off. And I'm using their PEX, the PEX build surface now, and that is fantastic. It's changed my life. Because now instead of spatula breaking parts, I just go boop, and it's off. And just let the parts fall. It's like my styrene parts coming out like butter. Now my 3D printed parts come off like butter. So that PEX material is really worth the money. I mean, it was a big investment. I think it was like $120 a printer to put that on my printers, but it's worth every penny, especially with the mass production I'm doing where my printers are running 3-4 days a week. It's really nice.
Right.
With that, I'm printing at bed heats anywhere from 70 to 80 degrees centigrade. And then now that I have magnets on my bed, I'm actually building like what they call elephant ears. So for instance, I'm putting a really fine part. I'll actually make a part that goes beyond that I clip off just to make sure this little piece holds in place. It's called an elephant ear. And I'll make it, and then I'll put a rare earth magnet on top of it. So after I put those first layers on, I got those cheap rare earth magnets I put right on. And as long as I don't go beyond 80 degrees centigrade, I don't hit that effect where the magnet loses its magnetism. And so for like a lot of these bigger pieces when I'm printing these car decks and stuff, I'll make those elephant ears, and then I just put some magnets on top, and then for another 15 hours, it prints the rest of it. But with the magnets holding it down, it ain't going to warp. It ain't going to pop off the bed at all.
Cool.
And then when it's done, let it cool down, and boop, and it's off.
Yeah, so you found that's the best way to keep from warping big, large parts then? With
big, large parts are always hard. So big, large parts, when I'm printing something really big and it's thin and I know it's going to work, I don't have a build chamber yet, like a heated build chamber. I just throw a trash bag over my printer, which is cheap insulation, and I put a clear plastic trash bag over it to keep the heat in, because warping happens when your bottom layer cools, but you're printing hot on top. It cracks it. It warps. It's thermodynamics. And so by putting that trash bag over and keeping the whole build's internal temperature at 56 degrees centigrade, it works a whole lot better. I'm actually building a new printer here right now that's going to be 16 inches by 64 inches for a build surface, and that's going to be completely enclosed so I can heat up that entire surface. I'm printing these 40-inch car decks in one piece.
Wow.
And so that'll be like a 3 to 4 day print. And with a part that big, you definitely want a heated build chamber so you don't get that thermodynamic peeling and cracking. But this is why you print in PLA and PETG and never ABS. No ABS. It's a mess.
Yeah, I think the PETG is sort of replaced the ABS as far as the strength, and you don't get the warping and the cooling problems that you have with the
Yeah.
ABS.
And ABS,
Right.
ABS has a lot of chemicals. It outgasses. You're supposed to do it outside. You're not supposed to have it inside your house. So PETG and PLA do not outgas and do not create like this nasty chlorine gas like ABS does. Remember, ABS is made in fuel refineries. It's got all the nasty stuff they took out of the fuel for environmental, and now it's in the plastic. So when you print ABS, it should be in a well-ventilated area, just like the resin should be in a well-ventilated area.
Wow.
Which is why I don't.
Yeah. Well, I think. Do you have any other things to show us, or any other parts to talk about?
To show how I put in the slicer and some of the settings I'm using to print that piece that we just made. So if I can show my screen again, I'll go into that, and I'll just take about 5 minutes and show that. And then if we have any questions at the end, I'd be more than happy to answer those.
Okay, sounds good.
So can you see my Simplify 3D screen?
Yes.
Okay, so I like Simplify 3D. It is a paid-for slicer. I believe it's $140. I've been using this for 6 years. Back in the day, Cura and some of the freebies were junk. Now they're better. There's a lot of options. But since I've been using Simplify 3D, since I've already bought it, I really, really like it. I love how easy it is to make setting changes. I believe Simplify 3D is one of the easiest slicers and most robust to use. So here you can see my 16 by 16 inch bed. That's in Simplify 3D. I'm going to hit import here. And I'm going to import that side panel mesh. It pops in. Notice it pops in the orientation of Fusion 360. I can then select it and put it on the bed, on the build surface. So here it is right here. And boy, this is weird sharing screen share. My Mac is acting weird. Anyway, you can see the part right here. And it's there. So in my slicer settings, again, this is Simplify 3D. I've got this set right now for a 0.2 nozzle diameter. We'll change that. And you notice my layer height is at 0.125. So it's 125 micron. What I was saying earlier, you don't want to go any higher than that. If I hit print on this, here's the render view. And you can see that it's got the little layers. Look at how many layers it's doing. 125 micron is actually thinner than most human hair. I mean, this is really, really thin. And good luck seeing it after you print it. And you can see that it just builds it up layer by layer. So there's a first layer, second layer, just layer by layer by layer, and just builds up my part nice as can be. So when I'm done with this, I can save the toolpath to disk. And this creates a file called G-code. It's a G-code file. And the G-code is a machine code language that the printer reads to print. 3D printers, except for Duet 3D, are pretty stupid. They just follow, go here, extrude this, extrude that, go here, go there, go up, go down, go left, go right. That's what G-code is. When you start getting into the Duet 3D stuff and some of the more sophisticated 32-bit boards, it's actually doing a lot more than that. I'm going to switch back to my camera. So my printer has what they call mesh bed leveling. There's no flat surface in the world. Glass is pretty close. And so my bed undulates. And so I've got this touch probe that measures the bed at temperature every time I print. And then as it's going on those first layers, it's actually going up and down a little bit. So my first layer is perfectly smooth. Even though it may not be perfectly flat, it's perfectly smooth on the bed. And so if you get a 3D printer looking to mesh bed leveling, especially if you get something that's bigger than 8 by 8 inches. So my machine is actually interpreting the G code and making something that prints very, very well. And that's what you get with some of the higher end components. A cheap Ender 3 or something like that isn't really going to do that stock. It's just going to print and go level. And if your bed's got a little bit of dip or bow in it, you're going to have blown parts. But basically, I make the 3D print in Fusion 360, and I put in my slicer, and then I do all the machine stuff. I set all my settings, my temperatures, when the fan kicks on, the bridging settings, so I can have nice bridging, I don't get droopage, all that gets set, and then that machine code then goes to the printer. So you basically got two hobbies. You got the 3D modeling hobby, you've got the craftsmanship of running a 3D printer and learning how it really works mechanically. This is why it's good to buy a cheap kit and really learn how these things work, guts and bolts, and do your own programming and figure it out, because that allows you to use a slicer much more effectively. And so I feel very comfortable with my printers because I built them. I've tightened every screw. I've drilled so many holes into them. I've done all the wiring completely. I've got custom power supplies. I've got all kinds of custom code running on them. And then my Simplify 3D also has some of that customization built into it in some of my startup and ending scripts and stuff and layer change scripts. In fact, I have it where I can put a little wire brush at the edge of my printer, and if I'm printing PETG and I know it's going to be stringy, I can add one little piece of code that after every layer, it goes over and goes over that wire brush, and then comes back with a clean nozzle and keeps printing.
That's cool.
So I've got stuff like that I've done just to make the printing easier. I've got code, for instance, if I'm printing lots of parts and I'm doing like 10 parts here, 10 parts here, 10 parts here, I've got it set that it does 10 parts, and then my printer beeps. And then just holds temperature and waits for me to come downstairs and make sure it's good. And what's cool is I use Wise cameras to look at my printers. Well, the Wise camera has an alarm setting. And so after that first piece, it goes beep, like a fire alarm. My Wise camera sends a push notification to my cell phone saying, you got a fire alarm going off. I look, oh yeah, those 10 pieces look good. I log in via VPN in my network, hit print, it continues going. And so I can print lots of parts complicated on the road, and my cell phone tells me when each part is done. I can look at it with the camera. It does a push notification because of the siren, and we're good to go. So I've really tweaked my stuff so it fits my lifestyle. I can go away on 3-day vacation, a weekend. I'll log into my printers, turn my printers on, heat them up, look at the cameras a day early, and I have a day's worth of parts sitting at my house when I arrive home. And believe me, you get into a dark garage, come in with all your dirty clothes and stuff, you go downstairs, you got a bunch of beautiful Model Road parts sitting waiting for you to glue together. That's kind of fun. But I don't like running my 3D printers for days and days when I'm not home, but I will fire them up for 12 hours or 14 hours before I get home or something like that. Mm-hmm. So just making the hobby work for you is really nice.
What scale are you printing? HO scale, O scale?
I do HO and O, and I have done N as well. So I sell kits in many different scales. I love O scale because it's so big and so tough. It just takes forever to print. But HO with a 0.2 millimeter, 200 micron nozzle, yeah, you can do a lot in HO scale. Really, really cool. Yeah. N scale, I've done a little bit simple stuff, but I'm never going to get the resolution for N scale that I get in HO. And talk to skill trains, I'm sure they see the same thing.
When you're doing the upgrades on your printer, do you just do one upgrade and then print with it and see how that works? Or do you do a lot at one time? What do you recommend that?
So what I did on these new printers is, since I've already upgraded the Wanhao i3 and the ANET 88, I just I went for it and I did all the upgrades at once. So I got the CR10s. The first one, I fired it up just to make sure everything worked, and then I ripped out the control board and everything. New power supply, new control boards, new wires, new motors, the linear rails, and I upgraded the whole thing and fired it up. And I did that for both machines, and it worked very well. But I'd already been 3D printing for multiple years. I'd already stripped my printers completely and upgraded them in many different ways. And so I felt comfortable doing that. With the new mega printer I'm building, it'll be the same thing where I just buy all the parts I know I need, I know I want, and boom, it's cool. It should be okay. I wouldn't have done that first couple of years, though. No way.
Yeah. Well, we're getting close to having to wrap it up here, but I've got a few more questions. Do you have a YouTube channel?
I do, but not for model railroading. But I do have a YouTube. I'm a Catholic priest by trade, so if you want to watch me at Mass and give homilies, you can see that. But I do not do model road YouTubing. I do stuff for my local groups and stuff. I do a lot of clinics. I do stuff like this, but I haven't been making model road videos. This is my hobby. Making videos seems too much like work.
Do you have a Facebook page or Instagram where you post pictures of your work? Okay.
No, I just do internal email chains to people and stuff. I don't do a lot of social media, unfortunately. Okay. My email is timoudenhoven@gmail.com. You can see my name on the screen. So if you want to email me, just email me using my Gmail. That'll be fine.
Okay, cool. Well, I appreciate you coming on, and that was an interesting clinic, and we're glad to have you here. So I think with that, we'll turn it back over to Martin and bring on the next guest.
Thank you much. Appreciate it.